This is 4.5 logarithmic properties. So some of you guys may have probably seen these properties in your algebra courses. So here we're going to expand a little bit on them. So there's three different properties that you should kind of know. The first one is the product rule. So what we say is that log base of A and B is equal to log base A of A plus log base A of B. So basically, if you have a multiplication in the inside of the log, regardless of what this log is, this log can be log base 10, log ln, natural log, any log, then all you can do is just break them up and then have log base A and log base B, and then this is going to be a plus. The quotient rule basically says that if you now have a division between two different things in the argument, then you can separate them by taking the numerator, and subtracting it by whatever's in the denominator. That's the quotient rule. And the power rule, basically what it says is that if you have a power on the log, then you can kind of bring it to the front, okay, as so, and this just turns into multiplication. So these are a couple properties. Now let me show you why these properties work. So I'm going to give you the proof. So basically what I'm going to say, if I want to prove number one, I'm going to let u be equal to the log base A of A. And I'm going to say v is equal to the log base A of B. Okay. So if I were to rewrite this as an exponential form, kind of like how we did in the previous video, then a to the u equals a. Let me write the u nicer. And then a to the v equals b. Okay, that's just using properties, rewriting the logarithmic into exponential. So now what I want to do is I want to figure out what exactly is log base A of AB. So I want to know what that guy is. All right, so now since I wrote the A as a to the U, so we know that log base A of A to the U, and then this guy is going to be times B, which is going to be A to the V. We know that by powers you can add them up when two things have the same base, multiply them. So you're gonna get log base A of A U plus V. Now remember that in the previous video, what we have said was that if you have the log base A of A to the X, then basically this is just equal to X. Okay, you can kind of think of the log A and the A canceling out, and you're just left with that X. So here you can think of this guy and this guy canceling out, and all I'm left with is U plus V. Well, I know what U and V are, okay? That's what we said, that U was equal to log base A of A, and then plus V was just equal log base A of B. Okay, so basically what we say now is that this first part, log base A of AB equals log base A of A plus log base log base A of B. So that's the proof for the first guy. Usually when we complete a proof, you can draw a little box with the box just fill in the box, and that just tells you that you're done with the proof. Okay, and we will be doing this whenever you see proofs. Now to prove part 2, we're gonna do kind of the same thing. So we're gonna start off first with the following. So we're gonna say that log base A of A, okay? So we're gonna start off with this guy, and what we're gonna do is we're gonna rewrite it. So we can write B somewhere in there. So what I'm gonna do is I'm gonna have this A, I'm gonna multiply this by B over B. So think of B over B, I can just cancel this out and it's just a 1. So I'm not really doing anything, I'm just multiplying it by a value of 1. So now what I'm gonna do, I'm gonna write it as log base A of A over B, and then times B. Now we already know what this guy is by properties of logarithms. So by proving part 1, we know that that's just log base A of A over B plus log base A of B. That's just by using the first form, because this guy and this guy can be broken up, and that would be an addition. So basically what we have is that log base A of A equals log base A of A over B plus log base A of B. And then finally, you can just subtract this over. Log base A of B minus log base A of B. And what we have is basically our log base A of A over B is just equal to log base A of A minus log base a of b. Okay, so this is basically what we wanted to show. Okay, and now to prove the third one, what I'm going to do is I'm going to let u equal log base a of big A. So if I rewrote this as an exponential form, it's just basically a to the u equals a. Okay, so now remember we want to figure out what this guy is, the power of c. So we know that a in this case, because we know what a is a to the u, so it's going to be a to the u times c. Okay, and now what we have is the following. So now we know that you have property that log base a of a to the x equals x. So notice how the logs a and the a is the same, so all we are left with is u times c. Okay, so let me write it again, c times u, because it's just the same multiplication. And then finally, I know what u is. U is just equal to this guy, which is log base a of a. And that's basically the third property. So this is kind of showing you why these work. They're not something that we just made up. You know, we actually know these by some little formal proofs. So so the formal proofs are just to show you kind of like as an FYI. So there's going to be two different things that we're going to be doing with these log properties. The first thing that we're going to be able to do is expand logarithms. Okay, and we're also going to condense logs. Okay, so these are the two different things. Expanding means that you're breaking up everything until you cannot, I'm sorry, you're expanding everything until nothing can be expanded anymore. Condensing is basically writing log as something in here. Whereas here, you just want multiple logs. Log of something minus log of something plus log of something. So that's basically what it means to expand it. At the end, the end result should kind of look like this. For condensing, the end result should kind of look like this. So you shouldn't have a number in front of the log. That's how you know that you did it kind of wrong. Okay, so here's my example. So we'll do a couple of them with expanding, and then we'll do condensing. So let's expand. Okay, so let's say we start off with log base 5 of x to the third y to the 6th. Okay, so you want to expand it until you cannot expand anymore. So the first thing that I see is you see a multiplication between two different things. So we can use the first rule, which is the addition. Okay, so the product rule. So we're going to take log base 5 of the first guy, which is x to the third, plus log base 5 of the second one, which is y to the 6th. Okay, so now we broke them up. We're still not done yet. Okay, and then in the end, you see how you have this 3 here? You can bring it to the front using property number 3. So this is going to be 3 log base 5 of x plus 6 log base 5 of y. Okay, here I can't expand anything else, so that means this is done. So maybe something that I can say is that there can be numbers in front of these guys. Okay, whereas this guy, you don't want a number. Okay, so let's try another one. So let's say we have the natural log of a over b divided by c. So remember that the natural log is just basically log base e. Okay, so the logs are still the log properties still work for natural log. All right, so notice that we see a division. I think that one's usually the easiest one to get rid of so that there's no fractions. So the fraction is going to turn into subtraction. So it's the first guy and then minus the denominator, ln of c. And now this guy, you have a multiplication, so you're going to break it up further. ln of a, this is an addition, ln of b minus ln of c. And this will be the answer. So let's say now we had the log of, I don't know, x cubed y to the 4th divided by the 6th root of z third. Okay, So first, we can see that there's a division. So let's get rid of the division first. So there's a division there. So you have log base 10 of x cubed y to the fourth. That's the numerator. And then subtract it by the log of the sixth root of z cubed. So notice here that this guy is an addition. So this is going to be a log of x cubed plus log of y cubed, or y to the fourth. Minus this guy, we can rewrite it as a power. So this is log z. This guy is going to be the numerator, the 3. And then this guy, the root, is going to be the denominator over 6. Okay? That's how you kind of rewrite that. So this is going to be log of x cubed plus log of y to the fourth minus log of z to the power of, this is just going to be 1/2. And now finally we can use property number 3. So it's going to be 3 log of x plus 4 log of y minus 1/2 log of z. And this will be my final answer. Okay? So what would this be? ln of 3x squared over x plus 1 to the 10th. Okay, so you see a division. So this is going to be the natural log of 3x squared, which is the first guy, minus the natural log of x plus 1 to the power of 10. So notice that this guy, you can actually further break it up as ln of 3 plus ln of x squared minus this guy, I can bring it to the front. So 10 ln of x plus 1. So then finally, this ln of 3 stays the same. The 2 can go to the front, so 2 ln of x. And then this guy stays the same. Oops, this should be a minus. And then this guy stays the same. 10 ln of x plus 1. Now, do not break this up, because this is not multiplication. It's not ln of x plus ln of 1. That's not right. Okay, that stays the same, because it's not multiplication. Okay? So now let's do something a little bit more involved. So let's say log of the square root of x times the square root of y times the square root of z. So I think the easiest way to kind of do it is break this up or get rid of the square root by making it to the power of 1/2. Remember, square root is the power of 1/2. Okay, so this is going to be the first guy, which is going to be x square root of y square root of z to the power of 1/2. That's the first guy. Okay, so let's bring out the 1/2 first. Let's take this with care. So it's going to be 1/2 log of x square root of y square root of z. Okay. Now let's work with the inside of the square root. So you have x square root. Oops. Well, that square root is going to be 1/2. So it'll be y square root of z to the 1/2. Okay. Now notice that this guy is just being multiplied to each other. So you're going to have 1/2. Oh, I forgot the log. Okay, so log of this x plus the log of this other guy, y square root of z to the 1/2. So I'm putting brackets around this 1/2 because remember that 1/2 is on the outside. It's going to be multiplied to every single thing in the inside. So now you have the 1/2 log of x plus, let's bring this guy to the front. So you have 1/2 log of y square root of z. And now notice that this guy can now be broken up again. So this is just 1/2 on the outside, log base x. You have another 1/2, and I'm going to break this up. Log of y plus log of z square root of z, which is basically z to the 1/2. Okay, and now I can just move this to the front. So it's going to be 1/2 log x plus 1/2 log y. Okay, plus, I'm going to bring this 1/2 over. But notice that there's another 1/2 that I'm bringing over, so there's two 1/2s there. And then log of z. So you're going to have 1/2 log x plus 1/2 log y plus 1/4 log z. And now finally, let's distribute the 1/2. So you're going to have 1/2 log x plus 1/4 log y plus 1/8 log z. So that was a lot, but it's still doable as long as you handle it with care. Okay, so just make sure that when you're doing problems like this, you do one thing at a time. Okay, you don't want to ever do these problems very, very quickly. Even if you feel like really confident in them, it's better to be sure. All right, so now let's do condensing. So condense into a single log. Okay, so let's say we have 2 log x minus 3 log y. So what you can do here is that you can first start off by bringing the 2 back forward. So we want to do the opposite. You want to have a single log by itself. So I'm going to do it the opposite way. So now this guy's going to be log x squared minus log y cubed. And now notice how you see a minus. So that's going to be log x squared over y cubed. So you're basically just doing the opposite. Okay. So what would happen if you had 1/3 log of x plus 1/2 log of y minus 3/2 log of z plus 1. So the first thing that we want to do is let's take care of those coefficients. So I'm going to put them back. So you're going to have log x to the 1/3 plus log y to the 1/2 minus log of z plus 1 to the power of 3/2. Okay, and now let's go. Do you see how there's some addition here? This is going to be multiplication. X to the 1/3, y to the 1/2. And then minus log of z plus 1 to the 3/2. Since there's subtraction here, this is going to turn into a division. So x to the 1/3, y to the 1/2, divided by z plus 1 to the 3/2. And that will be my final answer. So these problems aren't too terrible. We just have to make sure that we handle them with care. You don't want to be able to do you want to take them one thing at a time. So let's do one more. Let's do ln now. Ln of x plus 1 minus 4 ln of 4x, sure, and then minus 3 ln of y cubed. Okay, so let's handle one thing at a time. So let's move these guys first. So this is going to be ln of x plus 1 to the power of negative 3, then minus ln of 4x, the whole thing to the power of 4, minus ln y cubed to the power of 3. That's going to be, oops, it's going to be an ln y to the 9th. Okay, let me change this a little bit. Ln of x plus 1 to the negative 3. This guy is going to be ln. So then now we've got to do 4 to the power of 4. Will give me 256, and then x to the power of 4 minus ln of y to the 9th. I see a subtraction here, so that means that there's going to be a division. So the top guy is going to be x plus 1 to the negative 3, and the bottom guy is going to be 256 x to the 4th minus ln of y to the 9th. And then finally, there's another division, so it's going to be ln of So this is going to be x plus 1 to the power of negative 3 divided by 256 x to the 4th. Since this is being divided, I can just put it on the bottom, which is going to be y to the 9th. Okay, so that's a little trick that you can do. So if something else is divided, instead of having another fraction, you can just bring it on the bottom because it's going to be divided by the whole thing. Okay, so this is kind of how you condense and expand logs.